So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. So if you want to learn and master data structures and algorithms, or if you want to do really good at competitive programming, then this is a one-stop destination for you. Now before we actually get started, here's a quick reminder for you to hit that subscribe button if you haven't already yet. So in this video, we are going to solve this problem called XOR-ORED, which appeared in July Cook-Off 2021. The difficulty level for this problem is simple, and the prerequisites are the bitwise operators, which are the AND operator, the OR operator, and the XOR operator, right? And you should also be able to convert a decimal number into a binary number. The problem statement says that we have an array of size n, and in this particular case the size of this array is 3. Hence we have 1, 2 and 3 elements inside the array. And now what I will do is I'll simply replace a0 by a0 XOR x. I'll replace a1 by a1 XOR x, and I'll replace this a2 by a2 XOR x, right? This x is common for all the elements, right? And this x could be any number of our choice, right? After this, what I will do is I'll simply perform the OR operation among the new elements of the array, right? So now my aim is to minimize this complete expression. And for that, I can choose any number x of my choice, right? And I simply have to print the value of this x and the minimum value of the complete expression, right? If we have multiple possible values of this x, then we can print any value of x, right? And also it is also given that all these array elements, they would be non-negative, right? That is, these array elements could never be negative integers, right? So let's say the size of my array is 3. The elements stored inside my array are also 3, right? Now if I chose x equals to 3, then in this particular case I'll replace this 3 by this element itself, which is 3, XOR the value of x, right? The value of x is 3, so I'll write 3 over here. Similarly, I'll replace the second 3 by the element itself, XOR x. X is 3, so 3 XOR 3, right? And also the last element by 3 XOR 3, right? Now to perform this bitwise XOR operation, firstly I'll need to convert this 3 from decimals to binary, right? So 3 in decimals is nothing but 1 1 in binary, right? So I'll write 1 1 in binary instead of this 3. So 1 1 XOR 1 1 in binary, right? So let's calculate this 1 1 XOR 1 1. So this first bit over here is 1, and also over here is 1. So 1 XOR 1. So 1 XOR 1. 1 XOR 1 is equals to 0, right? So in binary, this last digit, this 1 and this 1 would fetch me 0, right? Because 1 XOR 1 is equals to 0. Similarly, again we have 1 XOR 1, right? So again 1 XOR 1 is again 0. So this would again give me 0, right? So 1 1 XOR 1 1 would give me 0 0 in binary, right? Which is 0 in decimals, right? So let me erase this. So this means that this 3 XOR 3 would be replaced by 0. Again this 3 XOR 3 would be replaced by 0, and this one also, right? And finally let me remove this, and finally I'll find the OR of all these elements, right? So 0 OR 0 OR, right? So the final value of this operation is 0 or 0 or 0, which is nothing but 0 itself, right? Hence, this 0 is the minimum possible value which we can achieve from these array elements if we chose x as 3, right? So in this particular case, the value of x is 3 and the minimum value of the expression is 0, right? So now let's move on to the approach. Now over here we can see that this expression contains bitwise operators, right? This expression contains bitwise operators. So what I will do is I'll write these numbers in their binary representation, right? Because writing them in binary form would make it much easier to perform the bitwise operators on them, right? So let's say this A0 is 0 in binary, and then we'll perform XOR operation, and let's leave the position for this X, right? We'll decide this X later. Then OR, then let's say A1 is again 0, then XOR, then we'll leave the position for this X, then OR, then let's say A2 is again 0, right? Then XOR, then we'll leave the position for this X, right? Now, whichever bit, I have two options to write over here, either 0 or a 1. Now, whichever bit I place over here, I have to place the exact same bit over here and here as well, right? Because we can see that this X is same for all the elements, right? This X is same for all the elements, right? So we have to place the exact same bits in all these three positions, right? Now, the first bit is 0. The first bit is 0 in all these three cases. I have to decide the second one, right? So I have these two cases, right? So should the second bit be 0 or should it be 1 to minimize the expression? The answer is simple. It should be 0, right? Because 0 XOR 0 would give us 0, which is smaller than 1, right? So I should take the second bit as 0, right? Because this would give us a smaller result. So I'll write 0 over here, because 0 XOR 0 would give us a smaller result. Similarly, I'll write 0 over here, because this bit would be same for all these three elements. So now the first expression would be 0 XOR 0. So 0 XOR 0 is 0, then OR, then 0, then OR, then 0, right? So 0 or 0 or 0 would give me nothing but 0, right? If I would have written 1, then this expression would have been 1, right? So if possible, by performing this XOR operation, we have to minimize this bit, right? We have to minimize this bit. Now let's take another case. This time A0 is 0, A1 is 1, and A2 is also 1, right? In binary form. So if I write 0, or if I choose 0 as X, so I'll write 0 over here and 0 over here. So now this expression would be 0 XOR 0. 0 XOR 0 is 0, so this would give me 0. Then OR, then 1 XOR 0. So 1 XOR 0 would give me 1. So 1 OR, then 1 XOR 0, right? So again 1 XOR 0 would give me 1. So this would give me 1, right? And if we are performing OR against multiple bits, then if all the bits are 0, then we will get 0, otherwise 1, right? Now since all the bits over here are not 0, so we will definitely get a 1, right? So if I choose 0, then I'll get minimum value as 1, right? So let's try to write 1, or let's try to choose 1 instead of 0. So this time I'll write 0 XOR 1, then 1 XOR 1 XOR 0 XOR 1, then 1 XOR 1, and again 1 XOR 1, right? So this time 0 XOR 1. 0 XOR 1 would fetch me 1, right? So this time it would give me 1, or 1 XOR 1. 1 XOR 1 would fetch me 0. This would fetch me 0. Then OR, then again 1 XOR 1, right? So again 1 XOR 1 would be 0, right? So again over here, since all the terms are not 0, so this would give me 1, right? So even if I choose 0 or 1, my minimum value would remain 1, right? So it won't change the minimum value, right? Even if I choose 0 or 1. So in this case, let's choose x as 0, right? Because we have to choose x. So let's choose x as 0, right? We can also choose x as 1, but that really doesn't matter. So now let's move on to the third case. So in the first case, all these array elements were 0. In the second case, they were a combination of zeros and ones. And in the third case, they are going to be 1, right? So in this case, A0 is 1, A1 is also 1, and A2 is also 1, right? So all the array elements are 1. Now for this x, I have two choices. Either I can choose a 0 or a 1, right? So let me write 0 over here, right? So 1 XOR 0. 1 XOR 0 would give me a 1, right? So I'll write 1 over here, then OR, then 1, then OR, then 1, right? So 1 or 1 or 1, right? So if all the elements over here would have been 0, then I would have got a 0. Since this is not the case, so I would get a 1, right? So by choosing a 0, I'm getting 1. If let's say I choose 1, then this time 1 XOR 1, 1 XOR 1 would give me a 0, right? It would give me a 0. So I'll get 0 or again 1 XOR 1, 0 or 0, right? So since all the elements are 0, so I'll get a 0 in this case, right? So to get the minimum value out of the expression, if all the bits are zeros, then x has to be 0, right? If we have some combination of zeros and ones, then x could be 0 or it could also be 1, right? And if all the bits are ones, then x has to be 1, right? To get the minimum value out of the expression, right? Now I can write this table in two different ways, right? That is, even if I follow the first table or even if I follow the second table, I would definitely get the minimum value out of the expression. So I can follow any one of these two tables. So this means that there are two ways to solve this problem, right? We can choose any one of these two, or at least there are a minimum of two ways, right? Now, if you closely observe these two tables, you can easily identify the relation between these bits and this x, right? So I want you to pause this video right now, take a couple of minutes, choose any one of these two tables and find the relationship between these bits and this x, right? So in the first table, if you can see that if all bits are zeros, then x is 0. If we have some combination of zeros and ones, then x is 0, and if all the bits are ones, then x is 1, right? So isn't it and operation, isn't it bitwise and, right? If we could perform bitwise and on all these array elements, then if all the array elements are zeros, I'll get a 0, right? If we have some combination of zeros and ones, and if I perform bitwise and among these elements, then I'll get 0, right? If all the array elements are ones, and if I perform bitwise and among these elements, then I'll get 1, right? Similarly, if you closely observe the second table, then you can see that if all the array elements are zeros, then x is 0, right? And if let's say I perform the OR operation among all these array elements, then if all the array elements are zeros, then OR will give me 0, right? If we have some combination of zeros and ones, then OR will give me 1, right? If all the array elements are 1, then it would give me 1, right? So now you have two ways of solving this problem, either by using this AND operation or by using this OR operation, right? You can choose any one of these two, right? So what I will do is I'll take this AND operation and I'll show you how to solve this problem using this AND operation, right? So let's again solve these three cases, this time using the AND operator, right? So in the previous slide, I told you that you can easily get the value of x by simply performing the AND operator over the array elements, right? So here we have three elements, 0, 0 and 0 in the first case, right? So simply let's simply find the AND of all these elements. So 0 and 0 and 0. So this would fetch me 0, which is the right value of x. You can verify this using the table. In the second case, we have 1, 1 and 1, right? So let's write 1 and 1 and 1. So this would give me 1, which is the right value of x. You can verify this again using the table. And in the third case, we have 0, 0 and 1, right? So I'll write 0 and 0 and 1, right? So this would give me 0, right? So this is also a correct value of x. So using this AND operation, we can easily get this value of x, and using a simple for loop, we can put this value of x in the expression a0 XOR x, then a1 XOR x, and similarly we can simply put this value of x to get the minimum value of the expression, right? Now, even if we have multiple bits, then also our approach would still work, because bitwise operators works on one bit at a time, right? In this particular case, I'll take the first bit of the first element of the array, I'll take the first bit of the second element, and I'll take the first bit of the third element, right? So here we can see that all these three bits are 1, right? So if all the bits are 1, then the value of x is also 1, right? So since all these three bits are 1, so in the first position, in this first place of this x, I'll write 1, right? Similarly, in the second bit, if I compare the second bit, so I have 0, 0 and 0. So if all elements are zeros, then I'll replace x with 0, right? So this time I'll replace x with 0, right? And in the third case, we have 1, 1 and 0, right? So we have some combination of zeros and ones, right? So I'll have to write 0 over here. So in this case, I'll write 0 over here, right? And in the fourth case, we have 1, 0 and 0. So again, we have some combination of zeros and ones. So I'll write 0 over here, right? Now, the value of x in this case would be 1,000,000, right? To get the minimum value out of the expression. And if we perform the AND operation of all these array elements 1,000,000, then also we can easily find this value of x, right? Because the AND of 1, 1 and 0 would be 0, 1, 1 and 0 would be 0, then 0, and then 1, 1, 1 would be 1, right? So even if I perform the AND of these three elements, then also I'll get the value of this x, right? So to get this x, I have to perform AND operation over all the array elements, right? Now, one way of doing this is to initialize this x with a of 0, and then using a loop, we can perform this AND operation with the rest of the array elements. Another way of doing this is to initialize this x with all of its bits set to 1, and I can write x as x and then a of 0, then and a of 1, and so on, right? So the first time this loop will run, it would calculate x and a of 0, right? So x and a of 0 would result in, so this is x, then I'll write and then a of 0. So this expression would result in a of 0, right? So I'll initialize x with all of its bits set to 1. Similarly, I'll initialize min with 0, right? Because 0 or with any value would result in a, right? So the first time I'll XOR 0, or the first time I'll OR 0 with this particular value, I'll get this value itself, right? So I'll initialize x with this value, and I'll initialize min with 0, right? Now let's see the code for this. So firstly, I'll create a variable t to store the number of test cases. Then I'll use a while loop to iterate t times, and then I'll create another variable n to store the size of my array, right? Now I can simply create a vector named arr of size n, right? After this, I'll initialize another variable and to -1, right? So what this line would do, or you can consider this as a hack of assigning all the bits inside my variable and to 1, right? So what this line would do, it would simply set all the bits of my variable and to 1, right? So now I can use a loop to iterate n times, and I can simply see in arr of I, and to get the bitwise AND operation over all the elements inside my array, I can simply write AND equals to and then bitwise AND operator and then arr of I, right? So this line would fetch me the bitwise AND operation over all the elements inside my array, right? So now I'll create a variable min to store the minimum value of the expression, right? And I'll initialize it to 0. So now I'll use the exact same loop to iterate n times. And this time I'll assign the value of min. I'll assign the value of min to min or then round braces, then arr of I XOR and, right? So this line would fetch me the minimum value of the expression, right? So let me print the AND, which is simply the x and then a space and then the minimum value, which is stored inside the variable min, right? And then a new line character, right? So now let's run the code. So here we can see that for the input 2, 2, or if the array contains 2 elements 2 and 2, then the output would be 2, 0, right? Or simply the value of x would be 2 and the minimum value of the expression would be 0, right? So let's submit the code for this. So let me paste the code. So this is the exact same code. This is the exact same code. So let's submit it. So submit, then okay. So here we can see that we got the correct answer.